So now we're going to talk about set builder notation. You see set builder notation, it's used. For our purposes, a lot of times we're going to put our answers in interval notation, but I'll show you the relationship. So we had a graph a minute ago. Let's see, we were at -2 and 5, I think. And we said, oh, we want the numbers greater than or equal to -2 and less than 5. And we were talking about all these numbers in between here. I switched colors, but okay, and we said, okay, well, we can write that as interval notation, square bracket, -2, comma 5. And hopefully it made some sense. We're going to do enough of it, you'll get used to it, but that's a picture of it. In set builder notation, we write it this way. It's the set of x such that x is greater than or equal to -2 and less than 5. This is like an in-between thing, okay? So it's like in between. It's some number in between -2 and 5. So in set builder notation, you have this line here. It's kind of a long line, and it's read such that. So we're talking about numbers, real numbers, such that, or here's the condition. The condition is the number has to be greater than or equal to -2 and less than 5. Okay? So it provides the conditions. It's written over there. All right, let's do another example. We had a graph at some point, or say we have a graph, and we're going to say x is greater than or equal to 10. So what we're saying is x is greater than or equal to 10. Well, then the way we write that in interval notation, square bracket, 10, comma, infinity. And that's pretty friendly and nice once you get used to the interval notation. And in set builder notation, it's the set of x such that x is greater than or equal to 10. So it's coming right from here, our statement, okay? But that's how you write it in set builder notation. Okay, so you'll see some of that. Just a couple more points on notation in general. Sometimes we have a solution that's all real numbers, right? We've had that before. And we might have it again. So the way they write that is in set builder notation, it's the set of x such that x is a real number. That is one way to write it. Another way to write it is to make the symbol for real numbers, which is a fancy R. Sometimes they write it like that, sometimes they write it like that. Anyway, I wouldn't do that too many times, because you have to remember that that's the symbol for real numbers. But anyway, in interval notation, which is most likely what we're going to do, all real numbers, that's the whole number line. Like if I'm graphing all real numbers, that's everything. There's a graph of the real numbers, right? It's the real number line. So in interval notation, it's from -infinity to infinity. Why do we put the parentheses? Because -infinity and infinity always get a parenthesis. And we always go from left to right. We're always reading that way, smallest to largest, okay? Now, we've also had cases where this solution was, there's no solution. You can't really graph no solution, so it'd just be like an empty number line. And as far as interval notation or set builder notation, they're probably just going to use this symbol for empty set. Sometimes they use the empty brackets like that, but you can just write the empty set symbol.